Microbiological safety cabinets are designed to protect the operator, the lab environment and work materials from exposure to infectious aerosols and splashes that may be generated when working with materials that contain infectious agents. Aerosol particles of less than 5 micrometers in diameter and small droplets of 5 to 100 micrometers are not visible to the naked eye, so the operator is unlikely to be aware of them. There are 3 types of microbiological safety cabinets, known as Class 1, 2 and 3. In a Class 1 biological safety cabinet, room air is drawn in through the front opening at a velocity of between 0.7 meters per second and 1 meter per second. It passes over the work surface and is discharged from the cabinet through the exhaust duct. This directional flow of air ensures that any aerosol particles that may be present on or around the work surfaces are taken away from the operator and into the exhaust duct. The air from the cabinet is exhausted through double high-efficiency particulate air filters, HEPA filters, either to the outside of the building through the building exhaust system or, in the case of a recirculating type, back into the laboratory airspace. The front opening of the cabinet allows the operator to reach the work surface inside and observe what they're doing through a glass panel. This panel can be fully lowered. It should only be opened for cleaning, servicing or equipment removal following fumigation. The Class 1 cabinet provides personnel and environmental protection and, because of its simple design, is still widely used throughout the world. The Class 2 biological safety cabinet is designed not only to provide protection for personnel, but also to protect work surface materials from contaminated room air. Class 2 cabinets differ from Class 1 by allowing only air from a HEPA-filtered sterile supply to flow over the work surface. Airflow in a Class 2 microbiological safety cabinet is measured as downflow. This downflow rate should be between 0.25 meters per second and 0.5 meters per second. An internal fan draws room air into the cabinet through the front opening and into the front intake grill. The air then passes through a HEPA filter before flowing downwards over the work surface. This downward flow splits about 6 to 18 centimeters from the work surface, one half of the air passing through the front exhaust grill and the other half passing through the rear exhaust grill. Any aerosol particles at the work surface are immediately captured in this downward airflow and pass through the front or rear exhaust grills, achieving a very high level of protection for the operator and the environment. The air is then discharged through the rear plenum into the space between the supply and exhaust filters located at the top of the cabinet. HEPA-filtered air from the exhaust can be recirculated to the room or discharged to the outside of the building through a dedicated duct or through the building exhaust system. But the efficiency of the cabinet airflow can be compromised by other factors such as overcrowding in the lab, rapid movement around the cabinet, open doors and windows, and overcrowding in the cabinet. The Class 3 biological safety cabinet provides the highest level of protection for personnel and the environment. The cabinet itself is a completely sealed, airtight unit. The air supply is HEPA filtered and the exhaust air passes through 2 HEPA filters. Airflow is maintained by a dedicated exhaust system outside of the cabinet, which keeps the cabinet interior under negative pressure, around 124.5 pascals. Access to the work surface is by means of heavy-duty rubber gloves attached to ports in the cabinet door. The Class 3 cabinet has a pass-through box attached that can be sterilised and equipped with a HEPA-filtered exhaust. or a double-door autoclave can be connected for the decontamination of all materials entering or exiting the cabinet. The first rule when working with microbiological safety cabinets is to protect yourself from the organism or agent that you're working with. For Class 1 and 2 cabinets, basic personal protective equipment such as gloves, sleeves and aprons should be used, as the operator's arms will be extended into the cabinet. When opening up a cabinet, there are a number of checks to go through. The logbook should be checked and filled in. Where appropriate, staff must check the fumigation unit is turned off. The fumigation indicator must be checked to make sure the fumigation cycle was successful. The fumigator should be turned off and the fan must be turned on. The alarm can be muted while the electronic or manual dampeners are opened. The night door or port can then be removed carefully to make sure the airflow is not disrupted. The cabinet dials should be checked to make sure they are in the correct and safe zone for use. The cabinet should be vented of fumigant, and any fumigated waste or equipment must be removed. For both safety and comfort, it's important to adopt the correct posture when working at a safety cabinet. The chair should be adjusted to ensure maximum comfort, with your arms placed well into the cabinet, not right on the edge. Your arms should be moved slowly to maintain the correct air inflow when moving them into and out of the cabinets. Prior to commencing work, laboratory staff must ensure that in-date decontamination materials are available in or near the cabinet. Disposal methods required, such as a sharps bin, decontamination tank and waste bag, must also be available. All materials should be placed as far back in the cabinet as practically comfortable, towards the rear edge of the work surface. For equipment that is aerosol generating, such as mixers and centrifuges, a Class 3 cabinet should be used where possible. Before working at a Class 3 cabinet, make sure all dampers are in the correct positions and that all necessary air intakes are open. Check the pass hatch is fully operational and closed. The integrity of the gloves has not been compromised, especially around the seals and at the wrist cuffs. And that there is a bottle of the appropriate decontamination solution placed inside the cabinet along with all the equipment you're going to need. Make sure the pressure dials are in the safe working zone before you start any infectious work. Once the cabinet is in use, all materials you're going to need must enter and exit the cabinet via the pass hatch, following the appropriate protocol. All materials that exit the cabinet must be surface decontaminated and placed in the pass hatch. Once work in the cabinets has been completed, the process of decontamination and clearing up can begin. Anything that comes out of the cabinet must be thoroughly surface decontaminated with Virkon or an approved equivalent. All sample containers must be surface decontaminated, clearly labelled in appropriate sealed plasticware suitable for low temperatures, and be stored safely in a freezer. Having removed the samples, you'll need to clean and decontaminate the cabinet. Waste that can be autoclaved should be surface decontaminated and removed from the cabinet and discarded into the appropriate waste streams. All cabinet surfaces should be thoroughly cleaned to remove any residual organic matter. The cabinet can then be prepared for biodecontamination. The appropriate method should be determined by risk assessment. When the clean-up procedure is complete and the cabinet is shut down, it should be given a final visual check to make sure that the door is secure. Any equipment or matter left in the cabinet should be fumigated in the cabinet. Once the cabinet has been cleaned, decontaminated and shut down, signage should be put in place to indicate the status of the cabinet. Once the working area is organised, has been cleaned and decontaminated and is ready for the next person, all required logbooks must be completed and any low stocks notified.